Hello and welcome to the Met Office Weather Studio Live. I'm Aidan McGivern. I'm a meteorologist here at the Met Office, broadcasting live from the Met Office operations here in Exeter. It's 1 p.m. It's Tuesday. We broadcast live every week through Facebook, through YouTube and through Twitter and Periscope. And you can write in, send us your questions. I will do my best to answer them. As you can see, I'm on my Todd this week. No friend with me this time, but hopefully you will send me more than enough questions to keep me talking. And of course, there is more than enough to get our teeth stuck into this week. Coming up, it's sudden, it's stratospheric, it's warming. We're talking sudden stratospheric warming with one of our top scientists here at the Met Office. What is it? And is there any sign of it to come this winter? But first, a real battleground going on with our weather this week. We have got weather systems to the east, we've got weather systems to the west, and we're stuck in the middle with, well, not much going on at the moment. Just need to reset the graphics there. Yeah, here we go. So we've got what we call a battleground here at the Met Office. With our weather through this week. We summarised it on our Instagram account yesterday. Here we've got cold air to the east, mild air to the west, and a bit of a swingometer there, just indicating that at times through the next few days the mild air will win, but at other times the cold air will edge a little bit further west as well. And by the end of the week, much of the UK is under the cold air, and that could get interesting into the weekend as weather systems try and push in from the west, bringing the risk of rain, wind and, yes, some snow. I'll be talking more about that later. But first, let's take a look at the weather over the next few days because, well, it's not looking quite that exciting. Although we are in this battleground, there's not a great deal going on. There's a lot of cloud across the country through the rest of Tuesday, some sunshine across eastern parts of England, eastern and northern Scotland. But we have got rain pushing in. This is Tuesday night now. Rain pushing into Northern Ireland, western Scotland, western parts of Wales, as well as Cornwall. Now that will keep temperatures relatively on the high side, but further east it will be chilly as we begin Wednesday, and there'll be a frost in places with those cold conditions continuing through the day on Wednesday across eastern parts of England. A big contrast further west, 10 degrees or so across western areas. A wind coming up from the south. Now, I mentioned a battleground over the next few days, and that's because we've got over to the east a large area of high pressure. This is something that we call a Scandinavian high, and that forms often in the winter over an area of cold, dense air. Now, this is dense and it is difficult to shift, and that's what's happened during recent days and weeks. We've got this cold, dense air just to the east of it, and it is going to push a little bit further across the British Isles over the next few days. A very frosty start, for example, on Friday across the country. Many places -1 to -4 degrees as we start off Friday. Some places, say, across central parts of England, East Wales, -5 to -8 degrees. But with that cold air entrenched across eastern parts of Europe into Scandinavia and eastern parts of the UK, we're also seeing, by the end of the week, a powerful jet stream come up against it. And this is almost like the weather equivalent of an unstoppable force meeting an immovable object. It's a real battleground, and in between we have weather fronts and we have the potential heading into the weekend for some interesting things to happen. Now, talk about battleground and weather fronts and so on. A lot of our weather terminology originated, well, just under 100 years ago after the First World War. So, you know, we talk about air masses advancing or retreating and fronts in between them. So a lot of this war terminology carries on to the present day, but certainly a battleground across us at the moment. And keeping with the war terminology, well, some winters the jet stream is much more influential than others, and in some winters the cold air to the east is much more influential. And what happens during those winters is that these systems have reinforcements. So, for example, the jet stream, we talked about this last week when we talked about teleconnections. The jet stream might have reinforcements in the form of the stratospheric polar vortex. And during other winters, when we get colder air coming in from the east, well, that air might have reinforcements in terms of something called a sudden stratospheric warming, or where we see the stratospheric polar vortex breaking out. What am I talking about? I think it's time we brought in our guest, Jeff Knight. Welcome to the Weather Studio. Jeff's first time on the Weather Studio. Top scientist at the Met Office. If you just briefly explain what you do here at the Met Office.
So, well, I'm a research scientist looking at climate variability on a range of timescales from just like a few weeks right up to decades ahead. So my job is to try and improve our modelling systems to capture all of these features, and the aim of that is really so that we can improve predictability.
And you particularly look at the next 1 to 3 months, don't you?
Yeah, so I'm in charge of putting together our thoughts about what's going to happen for our contingency planners forecast, which covers that kind of time scale and allows different people in different sectors like transport and the energy sector to have a feel for what are the more likely scenarios for what's going to happen over that kind of time scale.
It's not really a forecast that you'd see on the TV, is it? It's a very different type of forecast involving probabilities, and I mean, I often think of it as the odds on a horse race.
Exactly. So, you know, the weather forecast for the next few days is challenging enough, but when you're thinking about making a weather forecast for a month or 3 months ahead, obviously that's much more difficult. So what it means is that we can only really say that we think that certain situations are more likely or less likely, but ultimately we have to concede that there are parts of the weather system we just can't predict on these timescales. So we're looking at how various influences are like tipping the scales more one way or the other.
So those reinforcements that I mentioned, whether the jet stream will be backed up by other things
Absolutely.
that are happening around the world, or whether those cold easterlies over Scandinavia and so on will also have some reinforcements from elsewhere. So you're looking at the relative strength of these factors, aren't you?
Exactly. That's a good way to look at it, I think, is that you have something like the jet stream and the storm track, which to an extent have a kind of mind of their own, but they're kind of steered and influenced by these external factors.
And one big thing that people are talking about now for this winter, and we certainly saw a real classic example of it happen earlier this year, the stratospheric polar vortex and potential sudden stratospheric warming. Let's break it down. And first of all, what is the stratospheric polar vortex? Here's the jet stream. So we're all familiar with the jet stream. Now, the jet stream in a lot of our winters, it drives low pressure systems towards the British Isles. It deepens these lows, and we end up with wet, windy, but also mild conditions, people with umbrellas and so on. Now, that jet stream is high enough anyway. That's 25,000, 30,000 feet above the Atlantic, isn't it? And,
yeah,
and it
or
influences
about
our weather.
10 kilometres or so.
So 10 kilometres, there's the jet stream. Even higher up, what do we get there?
So higher up, we're thinking about what's going on in the stratosphere, which is the layer of the atmosphere that's above the weather. So thinking in the range from 10 kilometres up to about 50 kilometres. It's a very cold layer of the atmosphere where it's very, very dry as well. So there's not really very much in the way of weather as such going on there, but it does have a very important effect on our weather. So in winter time, we see this polar vortex form, which is a fast-moving current of air that moves around and around the North Pole, circulating rapidly at speeds up to about 150 miles an hour. And it's worth taking just a couple of minutes to think about how it actually forms. So if I said to you the stratosphere, what's the first thing that you would think about in terms of the stratosphere?
Ozone?
The ozone layer, absolutely right. So the stratosphere is home to the ozone layer. And so what's the importance of the ozone? What does it do?
I guess it protects us, doesn't it? It keeps
Absolutely.
the damaging UV rays off our precious skin.
That's absolutely correct. It's very important as a protective layer. That's why people are so concerned about it and worried about its future viability. So it's rather like if you go down to the beach on a summer's day. What would you take? You'd take your sunscreen.
Right. Yeah. We're always telling people here at the Met Office to make sure you put your sun cream on in the summer, or even when it's not cold. You've got to put even when it's cold, you've got to put your sun cream on.
So the ozone layer gives like 95% or so of protection from the ultraviolet radiation from the sun, whereas your sun cream does that extra little bit for you. So I don't know what sun factor you have.
Oh, probably not enough.
But say if
30,
you had 30 or something like that.
Yeah.
If you didn't have the ozone layer, you'd need something like some factor 5,000 or something like that. It's really very intense and nasty radiation that comes from the sun, and the atmosphere is doing the job. The stratosphere, the ozone layer, is doing the job of actually shielding that out. But do you, when you get back from the beach, ever think, what has the atmosphere done for me, today?
I don't. I'm so ungrateful.
Probably not. But in order to block all that really intense, nasty radiation, it has to absorb all that, and because it contains so much energy, it heats up a lot. And so the stratosphere is much, much warmer than it otherwise would be because of the ozone layer.
So it's heating up when the sun is in the sky, and then the sun goes below the horizon for a few months.
So yeah, that's the thing. In the sort of polar regions, of course, it's dark for a long time during the winter, for weeks and months. And that means that the stratosphere just loses its heat source, and it starts to get very, very cold indeed. And so what we have then is a very cold part of the stratosphere above the pole, whereas it's still relatively, and I say relatively, it's warm over the tropics and over the middle latitudes. So what we might have there is a difference in temperature of maybe like 30 or 40 degrees, and we all know as meteorologists, when you have difference in temperature, you have
wind.
Absolutely, and that's where this huge, great, sort of very strong current of air.
So that's driving these jets high in the sky, isn't it? So what happens when you get something called a sudden stratospheric warming?
Well, if that were the only thing that was going on, this sort of cooling effect, it would just cool all the way till spring until it actually got the sunshine back and started warming up again.
You're right.
But that doesn't happen. And one of the reasons for that is that the weather systems below this, in the troposphere, are actually kind of responsible for jiggling the system a bit.
Wobbles. They wobble it a bit.
The energy from it comes up and it can sort of jostle this polar vortex around a bit. And it's not kind of one individual low pressure system or anything like that, or a high pressure over here that's really responsible. It's kind of more the general pattern across the whole hemisphere. And when the patterns are right, they can push their energy upwards and displace the vortex. And so if that's strong enough, you can actually get one of these so-called sudden stratospheric warming events.
So it wobbles enough to break it in a bit, and then you get a warming of the core. Yeah,
so what you can see is sometimes it's just shoved right off the pole, and that it gets sort of destroyed that way, or sometimes it can be split into two pieces.
Yeah.
Either way, it's the whole circulation, the whole hemispheric circulation is disrupted and weakened.
You can see that on this graphic here. Now you've got the warm colours there pushing down, and all of a sudden the winds 50 kilometres high start to go in reverse, and of course they're then coming up against the jet stream below, so you start to see the jet stream weaken, don't you?
Yes.
And then in extreme examples, well, the whole pattern can go into reverse.
That's right. So we sort of replace the normal westerly winds with easterly winds at these high levels. And the tendency is for that signal to then propagate downwards through the stratosphere until it reaches the troposphere, the top of the weather, basically. And when it does that, it can influence our surface weather.
So 50 kilometres above the North Pole, it warms up rapidly, and then we get what kind of weather?
So when you have these easterly winds set up in the stratosphere, then it encourages easterly winds over us near the surface. And easterly winds in winter mean cold weather.
Pretty cold, yeah.
So
does that always happen, or is it?
So we're looking at sort of about 70%, roughly speaking, 70% of occasions after these events, we see cold impacts.
More likely than not, but not necessarily guaranteed.
But not guaranteed, no.
Yeah, because there are other things, obviously, that affect our weather patterns. Certain amounts of random variability comes into play often as well. So you can't always guarantee these things, but your job is to put probabilities down, isn't it? And to say this sort of thing is more likely in this sort of winter. Now, this chart here, it's going back 2 years or so. It's a temperature profile above the North Pole. The important thing here is it rises. There's the summer. It rises through the summer, and then it starts to drop off, as Jeff was saying. The polar night, it gets very, very cold. But this point here, this is February of this year, and then suddenly, boom, suddenly that stratosphere is warmed.
Very suddenly, yeah.
Right.
Yes, so we're talking down here, we're looking at about temperatures of about -80 or something like that, you know, at these very high atmospheric levels. And then within the space of just a few days, actually being able to reach up to maybe 50 or 60 degrees warmer than that. So this is incredible phenomenon that this warming happens. So this would be something like over the North Pole, for example. And it shows that the cold vortex air is just being pushed off and being replaced by a totally different air mass.
Yeah,
this warm air
and
mass.
we then ended up with the beast from the east, and everyone remembers that.
So
in March.
this happened on February the 12th, and so by about the 20th, 22nd of February, we were starting to see this upheaval in our surface weather patterns, and everything beginning to change around, and resulting in this very prolonged, intense easterly that delivered that very, very cold air and ultimately the snow.
It was such a strong signal at the time. I remember producing weather forecasts like the 10-day trend, in which we had this really clear signal, much clearer than we'd normally have, of very cold air on the way. And recently had an email into the Met Office that mentioned that, you know, they remembered this very clear forecast of the beast from the east and the mention of sudden stratospheric warming and so on. And what followed were a couple of cold spells in the spring and then that long hot summer. And this person who emailed in asks, you know, what happened to the sudden stratospheric warming? Did it continue to have an effect all the way through the summer?
No, well, I think, you know, we'd have to say no to that question, because as we've sort of described, the polar vortex is there in the winter. It's formed by the lack of the sunshine that getting to the ozone layer, and as the sun returns, it kind of warms out. So what you can see in this chart is here. In the summer, you get to temperatures that are sort of higher than they're actually after the southern stratospheric warming. This regime here, there isn't a polar vortex. It doesn't exist anymore.
Yeah, it can't be responsible for whatever summer weather we get.
Influence what's going on.
The £64,000 question, of course, is there a sudden stratospheric warming on the way, and what does that mean potentially for our winter? What can you say about that, Jeff?
Well, in our sort of long-range outlook so far this winter, what we've been saying is that the probability of cold happening is probably more likely later in the winter. So this year we've got a moderate El Nino event, and when we have those, what tends to happen is it favours more mild and wet and westerly weather in the early part of the winter, then a transition later to a higher chance of cold and dry conditions. So given that framework, that's kind of like what we think is more probable. So, you know, we have seen quite some reasonable mild and wet weather in the recent weeks, so that is at least consistent with it. But we would expect that there's more chance as we go sort of beyond Christmas,
Because of El Nino, because of these sea surface patterns and weather patterns in the Pacific, that then has an impact on the stratospheric polar vortex, and it all feeds back into
exactly. I mean, these things seem slightly peculiar, I guess, to some people, that something so very far away can actually have an influence on us. But the weather system is intricately interconnected on the sort of timescales of a few days, in fact. So signals from far away in the Pacific can then move into the North Pacific, then that can affect the polar vortex, which then can affect us. So, those things those ripples can propagate out across the pond, for thousands and thousands of miles.
And we will be monitoring them very closely to see what it will mean for our winter and the weather to come here in the next few months. Very, very interesting.
Yes. So I think in the next few weeks, I think we're looking at the polar vortex very, very carefully, to see what's happening. So it has, in the last few days, started to sort of oscillate in strength a bit. So we see these repeated cycles of weakening and strengthening. And it looks like it might go through another one of those, but I wouldn't be surprised at all if we were looking at another southern stratospheric warming come sort of New Year, really.
But it's certainly no certainties.
By no means.
Right now.
By no means.
We will keep you posted. I'm sure we'll cover it many more times here on the Weather Studio. Thank you very much, Jeff Knight. It's been a pleasure chatting to you, and keep on the good work with the seasonal forecasting. Excellent.
Thank you very much. Cheers.
A few questions have come in. I noticed my phone buzzing away there. Lee Davis on Facebook just chatting about what we were talking about there, the stratospheric warming causing the jet stream to dip, pulling in polar vortex. Am I wrong? Well, yeah, there may be some signals of that happening. You may not be wrong there. Will it be a white Christmas? Well, if we did get a sudden stratospheric warming even now, then the impacts on our Christmas weather may be a bit early for that to be happening. But at the moment, there are no strong signals for a white Christmas. We will, of course, keep you updated here at the Met Office. It's looking very changeable in the run-up to Christmas, with some quieter, colder weather or some milder, wetter weather. So I think we'll keep the changeable weather going through till the end of the year at least. Christopher Hannaford asks on YouTube, it's felt unseasonably mild lately. Are there any signs of proper colder weather periods coming? Well, if it is snow you're after, depending on where you live in the country, there could be some snow this weekend, but it's looking very messy as we head into the weekend, and certainly very uncertain. We've still got the block that I mentioned out towards Scandinavia and the very cold air out to the east as we kick off the weekend. But look at this. At the umpteenth time of trying, we've got weather fronts finally making it in across the UK through Saturday. Now, although there's still some uncertainty, because when weather fronts from the Atlantic move up against this cold block, it always adds difficulties. It does look increasingly likely that they will make inroads. Now, depending on the timing of these low pressure systems and depending on their shape and the angle of attack and so on, well, we're likely to see some severe weather in some parts of the UK, but different types of severe weather depending on where you are. So let's deal with the snow first of all. I rewind that and put the weather layer on, then you can see cold air entrenched across the UK. Now, as we head into Friday night and into Saturday, and this is just one computer simulation, as we head into the weekend, a lot of the different computer simulations start to do that. They diverge, and that leads to very high amounts of uncertainty. But it does look likely that as these weather fronts move in, they're carrying rain, they're bumping into cold air, they're likely to give some snowfall. Where exactly is, well, that's the big question. It looks most likely to be lying snow over northern hills, so the Pennines, North York Moors, the Scottish mountains, the Welsh mountains as well, for example. But even at lower levels, we could see some falling snow or even some temporary lying snow, particularly, say, northeast England, eastern parts of Scotland, even somewhere like Heathrow. Don't be surprised if you see a few big flakes of wet snow coming through at first on Saturday before the rain sets in, but we're not expecting at this stage significant snowfall for southern counties of England and Wales. So certainly the further north you are, the higher up you are, the more likely you are to see snow through the weekend. So that's the first thing to watch out for through the weekend. The other thing is the rainfall, and of course southwestern parts of England in particular, South Wales. We've seen a lot of wet weather recently. There's more on the way for the weekend. This is unlikely to be snow. This is more likely to just be rain through Saturday and Sunday. You can see it setting in there. And the final thing is the wind. It's likely to be windy everywhere. That will make it feel cold, but there are some computer simulations that develop a deep low later on Saturday and into Sunday. This is one simulation that shows a swathe of gale force winds hitting particularly western and southwestern parts of Britain. So that's another thing that we need to keep an eye on. But it is by no means nailed, because these are two different computer simulations here, and you'll see how there are subtle differences that will make a big difference by the weekend in terms of the kind of weather we get. Now, this on the right here, this is the Met Office computer idea, and that's got a deep low for Sunday. Very little sign of that from another computer simulation. So this deep low in the Met Office output, that comes along and pushes in strong winds. On the other computer output, it doesn't have that. The other way that they differ is that the cold air is much more entrenched across some computer simulations than others, and that would lead to a greater risk of snow for, say, eastern and northeastern parts of Britain. So lots of things to play for as we head towards the weekend. We will certainly keep you updated here at the Met Office. It's 5 days away, so as the weekend approaches, hopefully those computer ideas will start to converge again and we'll get a better idea of what's going on. But certainly wind, rain and the potential for some places of snow as we head into the weekend after what will be essentially a few quiet days of weather. So yeah, you can keep up to date with all our latest thoughts on all of those things through our social media channels. Thank you to Jeff for talking about sudden stratospheric warming, and thank you for your questions as well. I better wrap it up because 25 minutes of me talking on my own is more than enough. And thank you for tuning in if you hung about long enough to listen to this bit. I will see you again next week.